Hello, Luke. Welcome to Lesson 59. Today we're actually skipping a lesson, if you didn't catch on to that right away. Instead of Lesson 58, we'll be doing Lesson 59 today. I just thought that Lesson 59 would be a better lesson for a Friday class right before the weekend. And then on Monday, we'll come back and go and do Lesson 58. I just think it works out a little bit better. So, today, Lesson 59. A fairly straightforward lesson today. That's why I chose it for a Friday. Today we're going to be talking about solving systems of equations again, and the only difference now is we're going to take one extra step and rearrange before substituting. So you recall in a previous lesson we talked about systems of equations, and that's where we have two equations that are kind of joined with this brace on the left-hand side. And all that indicates is that whatever value is hiding behind this x, it's the same value that will be hiding behind this x. And whatever is hiding behind this y will be the same value behind this y. All right? So it just means that the x's are equal in these two equations. And we're actually trying to find the ordered pair that satisfies both of these equations. And that's just review. That's what we've already learned how to do. This first one is exactly the kind of problem that you've been seeing up to this point. And we've been solving this by using the process called substitution, right? And that's where we look at these two equations and we say, okay, well, here we have x is equal to 2 plus y. So why can't we just take this x equals 2 plus y and substitute that in for this x in the first equation, right? So we substitute in this 2 plus y into this x in the first equation, and then we have an equation that just has y's in it, and we can solve for y. And then we can finish by plugging y back in and solving for x, right? That's what we've been doing up to this point. Another possible scenario, just a different variation of the same problem, is this second one here. And this one, we have again two equations, but now we have the y is equal to something. And again, we just say, well, why don't we just take this y, this 2x, which is equivalent to a y, and plug it in for the y in the first equation. And then we can solve for x, and then once we've solved for x, we can solve for y, right? So both of these first two problems you've done before, and hopefully would not have a problem doing them now. But maybe just to kind of sum up the review here, let's just do one of them. I won't do both of them, but we'll do one of them. So let's do the first one and see how that turns out. So again, we're using substitution. So since we know that x is equal to 2 plus y, we plug that into the x in the first equation, and we end up with 2y plus 2, but not an x. Now it's a 2 plus y. We're substituting that in, 4x, okay, equals 12. And now we just start solving this. So we can simplify 2y plus, now we can multiply this out using the distributive property to get plus 4 and then plus 2y is equal to 12. And then we have a 2y plus a 2y is going to be a 4y plus 4 is equal to 12. And then we can subtract the 4 from both sides, and we get 4y is equal to 8. And then we can divide both sides by 4, and y is then equal to, is equal to 2. All right, so that's part of our ordered pair. Now we can take that y is equal to 2 and plug that back in to either one of these equations to solve for x. We'll just choose the second equation. So we have for our second equation x is equal to 2 plus y. But now we can substitute this y in, this value of 2 for the y. So we have x is equal to 2 plus 2, which is equal to 4. So x is equal to 4, y is equal to 2, so our ordered pair is 4, 2, because remember, when we have an ordered pair, we always write the x first. So 4, 2 would be the solution to this system of equations. Now, I went through that pretty quickly, but that is just review. Let's look at this next problem. This is what our focus will be on for this class. So in this problem, look at it closely. Can you see a difference between this problem and, something like this, the previous problem? Just take a minute and study that problem. What's different about it? Okay, so maybe you noticed the difference here is we don't have an equation that's in the form of y equals something or x equals something. Both of these previous systems of equations had that. So here we had an x is equal to something. Here we had a y is equal to something. In this third system of equations, we don't have anything like that. We've got everything kind of all mixed up. There's nothing nice and simple. There's no x equals, y equals. Okay? So how do we solve for this kind of a system of equations? And the answer is it's very simple. We're going to do the same thing we've always done, but there's going to be one additional step. And that is we first need to rearrange one of these equations so that it is in the form of x equals something or y equals something. Okay? Now we have some freedom here. It doesn't matter which variable we choose to solve for, nor does it matter which equation we use to set into this form. Okay, so there are many different ways that you could solve this, all of which are legitimate and are, good ways and proper ways to solve this system of equations. Later on, we'll even learn more ways that you could solve this. But for right now, you need to just decide which equation and which variable do you want to use to solve for. Okay, so looking at it, it basically boils down to your preference. But as you do these problems, you'll develop kind of a knack for seeing the equation that will be easiest or easier to solve for a particular variable. So when I look at these equations, I see that, in the second equation, my x and my y's, they both have coefficients of something other than a 1. So I have a 3 for my coefficient for the y, and I have a 2 coefficient for the x. In the first equation, I have a 2 coefficient for the y, and I have a 1 coefficient for the x. I actually like this first equation. And the reason I like it is because this x doesn't have a coefficient other than a 1. Okay, it's already by itself, you could say. So I'm actually going to take this top equation. And the first thing that I'm going to do is solve for the x. Now, I could solve for y if I wanted to, but just based on what I'm seeing, I think the x is going to be the easier one to solve for. And why work harder than you have to, right? I mean, really. So let's do it. If I'm solving for x, I need to get x by itself. So I have, and I'll just rewrite the equation here, and we can start with that. So we have x minus 2y is equal to a negative 1. If I want to solve for the x, I'm going to add 2y to both sides. All right, and that would eliminate, and I end up with x is equal to negative 1 plus 2y. And there we go. I am already now in that form that I'm after, that I'm hunting for. I'm in one of these forms. I'm in this form. X is equal to something. Okay? That's exactly what I wanted. So I can then, maybe, let's see here. Maybe we'll just rewrite these two. So the first equation, all I've done is rearranged it so that I get it into this form. So I'll just rewrite it in that form. X is equal to negative 1 plus 2y. And then I still have my second equation that I haven't touched. That's 2x minus 3y is equal to 4. But now I am in the same form as I was in the first two problems, right? I'm now in a form of of a system of equations where there is an x is equal to something. So the rest should be review. Now I'm just going to take what I know, this negative 1 plus 2y, and plug that in for this x in the second equation, and then solve for y. So let's do that. We're going to substitute that in. So we have a 2, which I'm getting from here, the second equation, a 2x, but we know that x is equal to, and I'm going to put this in parentheses, very important, negative 1 plus 2y, that's the x, right here. Then I have the minus 3y is equal to 4. Okay, so now I can work this equation, starting with distributive property. Let's distribute the 2 through. So 2 times a negative 1 is a negative 2. 2 times a positive 2y is a positive 4y. And then I have minus 3y after that is equal to 4. Now I can combine like terms here. I have a positive 4y and a negative 3y. Well, that's just going to give me a y. So I end up with a negative 2 plus y is equal to 4. Now I can add 2 to both sides. And that will give me y is equal to 6. There we go. There's part of my solution. Now I can go back and plug y into either one of these equations. It doesn't matter which. I'm going to choose the first one. So I have x is equal to negative 1 plus 2 times y, but I know that y is a 6. So I'll put the 6 in for the y. That's going to give me a negative 1 plus 12, which is going to give me an 11. So x is equal to 11. So the ordered pair that is the solution to this system of equations is 11, 6. There is my solution. All right, so not difficult. The only new step here is rearranging one of the equations so that it is in the form of x is equal to something or y is equal to something, whichever one's easiest. All right? Excellent. All right, let's try this one. And actually, I want you to do this on your own first. So pause the video, give it your best shot, and then we'll try it together. All right, so hopefully you did well. If not, after we do this, look at what you did wrong and make sure you don't do it again. So, all right, let's try this. Okay. Now you may have chose something different, but I'm looking at this again and going, okay, I have, coefficients on all of my variables except for this y right here. And anytime there's a coefficient without a variable, it's just easier to solve for that. So that's the equation that I'm going to use, and I'm going to solve it for y. So this equation becomes, let's see, I'll rewrite it first. 2x plus y is equal to 10. And let's solve for that y now. So we're going to subtract the 2x from both sides. It's as simple as that. And that's going to give me y is equal to 10 minus 2x. Okay? So now my new system of equations here, which is really the same thing. It's just the first equation's been reorganized. We have y is equal to 10 minus 2x. The second equation is the same, 3x plus 2y is equal to 8. Okay, so there's my system. Now I see that the y is equal to this. I can substitute that into the second equation. So let's do that. Maybe we'll do a different color here. Oh, I don't know. Let's do this. Okay, so we have 3x, taking that second equation, plus 2 times a y, which is this. So 2 times 10 minus 2x is equal to 8. Now we can do some simplifying. 3x plus 20 minus 4x is equal to 8. We can combine a couple terms here. We have a 3x and a negative 4x. That's going to give me a negative x. And I'm going to start doing some of this in my head a little bit. This positive 20, we're going to subtract it. And that's going to make it 8 minus 20 on the right-hand side. and we end up with negative x is equal to a negative 12. Now I can divide out the negative sign by dividing by a negative 1, and that'll give me just an x then, which is equal to just a 12, right? So x is equal to 12. Now we can go back, plug the x in, and I'm going to choose, well, let's choose the first equation. So y is equal to 10 minus 2 times x, and x is 12. So now y is equal to 10 minus 24, which is going to be equal to a negative 12. So y is equal to I'm sorry, not a negative 12. Hopefully you caught that. What am I doing? That's a negative 14. 10 minus 24, negative 14. So is equal to a negative 14. All right, and so our ordered pair is 12, negative 14. There we go. There is our solution to this system of equations. If we plug 12 and 14 in, we should end up with true equations for both of these. Okay? Excellent. All right, so let's try another one. So why don't you go ahead and pause the video, try this one on your own, and then we'll do it together. All right, so this one again, we see that this y is actually the easiest one because it doesn't have a coefficient. But you know what? Just to shake things up here a little bit, why don't we solve for something else? Let's just make it a little bit hard on ourselves. And the only reason I'm going to do that is just to show you that it doesn't matter which one we decide to use. All right, so even though I think y would be the easiest one to work with, let's choose a harder one. Let's just solve for y. Maybe we can even solve for x. Let's solve for y up here on this first equation. So 4x minus 2y is equal to 38. And let's solve for y. So we have, let's subtract the 4x from both sides. And that's going to give us a negative 2y is equal to 38 minus 4x. Now I can divide everything by a negative 2. If I divide everything by a negative 2, they're going to cross out. We're going to end up with a y. 38 divided by a negative 2 is a negative 19. And then a negative 4x divided by a negative 2 is going to be a positive 2x. Hopefully you see that. I'm just dividing every term in the numerator by the denominator. That's legal. I can do that. So 38 divided by negative 2 is a negative 19. And then a negative 4x divided by a negative 2 is a positive 2x, because a negative divided by a negative is going to be a positive. 4 divided by 2 is 2. All right? So hopefully you see how I got that. Now we know what y is equal to, at least in terms of x. Let's plug that into one of our other equations here. Let's plug it into the second equation. So we have 2x plus a y, which we now know is a negative 19 plus 2x is equal to 25. All right, and here we would say, okay, 2x, well, the positive is not going to change any of the signs in here, so it's just going to be 2x minus 19 plus 2x is equal to 25. We can combine some like terms here. We end up with 4x minus 19 is equal to 25. And then we can add 19 to both sides, and we end up with 4x is equal to 44, right? And then finally we can divide by 4, and oh, it's just wonderful how these work out. This is going to be x is equal to 11. By the way, these are contrived problems for the most part, so we end up with these really nice answers like 11, but there's nothing in the rule book here that says that we have to end up with nice answers. We could end up with some really nasty fractions. It doesn't mean we're wrong. It just means we have a nasty answer. Okay, but In general, the book does seem to try to make things nice for you, and you do tend to line up with nice whole number answers. But just kind of bear in mind, in the real world, it's kind of unusual to end up with such a nice answer here. But anyway, I digress. So we have x is equal to 11. We can now plug that into either of these equations. You choose, which I guess you can't because you're watching a video, so I'll have to choose for you. Let's choose the second one. So we have 2x, which we know is an 11 now, plus y is equal to 25. So 2 times 11 is 22, plus y is equal to 25. We subtract. This should be just becoming just a habit now. You should be able to do these in your sleep. 25 minus 22 is 3, so we end up with y is equal to 3. So our final ordered pair solution is 11, 3. There we go. That would be the answer to this system of equations. All right. Very good. So that is really all we're dealing with today. It's just rearranging the problem before you substitute. So hopefully that makes sense. If you did not get that answer, make sure you rewind this video and look at your work and understand what it is that you did wrong so that you don't do it wrong in your seat work. And if you got it right, great. Then you are ready to go. So we will stop there, and I will see you tomorrow.